Alright, well, welcome to the second lecture on lists. Now let's do a problem here. Construct the list this using only cons and the empty list. Alright, so how are we going to do that? Remember how we did 3 and 4. Remember how we did the list 3, 5. It was like this: cons 3, cons 5, and that. Now, do you see any similarities between 3 and 5 and that list containing 2 empty lists? Here, suppose we replace 3 with an empty list, oops, and then 5 with an empty list. Now, and we'd have it. So let's just take this definition and replace the 3 and the 5 with an empty list. There we go. That's about it. Alright. So what about this list? How would we how would we construct that one? So it's got a list with an empty list inside of it with a list with a list with a list. So 3 lists. So we'll cons that and that for the first one. Now what happens if we just cons that into that? Oh, that's not what we wanted, is it? No. So basically we've got to cons this empty list into the center empty list, which is the car of this list here. So do cons into that and put it into that, and there we've got a list. Alright, now if you want to think about lists in a different sort of way, you can do it with pictures. Let's see if this will get pasted in here. Okay, and there we go. Okay, so there's a list of 10 and 20. There you just see the items in the list are kind of in the second branch. So this one, it's a list of 20, and then another list that contains 30 and 40. Alright, then this one, it's just 1, 2, 3. That's pretty obvious. So let's try drawing a picture of this list here. 1, 2. Okay, now that's a list within a list, isn't it? Well, it's sort of hard to draw a picture of this, but I'll just copy and paste one that's already been drawn. You just think about it. Alright, there we go. So 1, 2, the list that goes down to a list here, and that's a list of 1 and 2. Now, alright, so let's try alright, so that's about it for lists. So I've showed you how to access them, to access things out of them, and I've showed you how to construct them. Now we're going to introduce predicates, and let's see. Yes, data forms. First of all, the things you've seen so far are numbers, which are just numbers, symbols which have the quote on them, I, and then lists and pairs. And you've not actually seen pairs yet. That's like cons A, B. That's a weird like dotted pair thing. You don't have to worry about that. Alright, so now there's a new one called booleans, which are just true and false. Now in scheme you represent true with a pound sign and then a T, and then false with a pound sign and a false. And they are the response of predicates. Predicates are functions or procedures that always return either true or false. So here's a predicate that tests if numbers are equivalent. 3 and 5 are 6. That's false. Equals 3 and 3. That's true. And it's generally used to perform tests, and used quite often. Now we can test the types of things, like let's test. Remember, we can test if a list is empty with the null predicate. Yes, it's empty. Null. No, that's not empty. Alright, now we can find out about types too, like list. Yep, that's a list, but it's not a number. There. So what is a number? That's a number. Alright. And then there's other ones too. Here's a full list of them. Right there. You test for number, symbol, boolean, list, pair, null, and procedure. Alright. Now equivalent predicates. So as I showed you already, equals is used for numbers. But if you want to do symbols, you can't use that. Equals pi. No, can't use it. Remember, we still have pi defined now. If we do equals pi and pi, that's just two numbers, so that's fine. But the quoted pi is a symbol, so you can't use that. But you can use EQ for pi and pi. But does it work on numbers? Yep, it works on that as well. Alright. Equiv with a V. That is used on symbols, booleans, and numbers. Like that's true, false. No, it's not equal. Alright, but we couldn't have used that. Oh, we could have used that as well. And equal is sort of like, that does everything. You can like test and see if lists are equal. Yes, that's equal. Now we can change that a bit. And no, that's not equal. But I'll bet you equiv couldn't work on that. Let's hope not, otherwise, you know, I'll name them all different things if they all do the same thing. Oh yeah, well, maybe. So A, B. There. Well, that works too. Alright. Alright, so let's see. But so basically the only two you'll probably ever want to use is the equals one, and then this equal where it's written out, the full sign, because this will pretty much handle everything. There are some things that equiv doesn't work for. Oh, I can't seem to find them right now. Alright, and then we're going to use that in if statements and in functions and things like that in the future.